Hello children, welcome to channel Sube. Children, today I am going to discuss question number 31 from the MCQ part of 2021 Physics new syllabus paper. A student used the potentiometer circuit shown in the figure to determine the internal resistance simple R of cell E. So this one. When key K is opened, the balance length simple L is 60 centimeter, and when key K is closed, the balance length is 50. So that means this key is like this. We call it is opened. So the key, when the key is like this, closed like this, it is closed. So let us take this one closed. This one is called closed. This one opened. So like that. What is the internal resistance of cell E? Cell E means this one. Simple R is what they want. Want us to find simple R, this one. So children, first of all, do you notice that this circuit is wrong? This is not like this. This resistor is placed here to protect the galvanometer, but according to the way they have fixed it here, no protection is given to the galvanometer. So it should be like this. The galvanometer, let us move a little bit here, and we have to place this resistor series with the galvanometer. I think that mistake must have done by the typesetting person. The original paper might have the correct form. So it should be like this. So first of all, change your diagram. If you make a note like this, it should be like this. The resistor was parallel earlier, but now this one also should come here like this. So it should be like this. So they say when this switch is opened, the length is 60 centimeter. So let us take a copy to here. So we don't want this one. When this switch is closed like this, switch is closed, the length had been 50 centimeter. Yes, that is correct. When the switch is closed, this length decreases, therefore it is correct. So I will show you first of all what is the short method, and later I will explain everything. You should remember V equals ER divided by R plus R equation to solve this problem. This equation we use in simple circuit. We call simple ideal circuits. We use this equation for that. So when we go to the potentiometer principle, if K is the potentiometer constant, that means the drop of voltage per unit length, then we can write here E equals K times 60. K times 60. For this circuit we can write there is a voltage now here V, not E, because current is passing through this resistor now. Therefore V equals k times 50, the balance length. So applying this, substituting these two expressions to this one, what is V? V is k times 50. What is E? K times 60 multiplied by, what is R? R is this 10 ohm divided by again 10 ohm plus simple R, that we don't know, internal resistance of the cell. So K cancel, then 0 cancel, then phi equals 60 divided by 10 plus R, then cross multiplication, then 50, 5 times 10 is 50 plus 5R equals 60, then 5R equals 60 minus 50 means 10, then R equals 10 divided by 5 is 2. So that is the answer, this one. Third one is the answer for 31. Third one is correct. So children, if I explained a little bit about this question, this equation you should remember how it comes. I will show you how it comes. So you have to apply the energy law to this secondary circuit. This one we called ideal circuit, ideal simple circuit. So this circuit, so if the electromotive force is capital E and internal resistance simple R, if this resistor is capital R, then if the voltage is V, if the current is I. Conservation of energy, the power given by the cell is E times I, that is the definition of E. So E times I. So power dissipated by the resistors, power as heat, you know, from Joule's law, I squared capital R plus I squared simple R. There are two resistors here, 1 and 2. So power dissipate as heat from those resistors, this amount, say this one first, this one second. So first one must be equal to the second one according to the conservation of energy. So therefore we can write EI equals I squared R plus I squared simple R. So I cancel, then E equals I R plus I simple R. So I is common, brackets R plus simple R. So this is the equation we use normally for ideal circuits. So then V equals IR, V equals IR. From here we isolate I, I equals V divided by R. Then we substitute it here, then E equals V divided by R times R plus R. So we isolate V equals E times R divided by R plus simple R. So this is the equation that we use to find internal resistor of a cell. So that is what I used here at the beginning when I was solving this problem. So this equation is valid for this circuit. This equation is valid for the potentiometer. This one also to the potentiometer, because we take the readings when the galvanometer is 0. When the galvanometer is 0 means no current is passing through this galvanometer. Therefore, there is no potential difference. If there is no potential difference, the potentials at these two ends of the galvanometer must be equal. Potentials are equal. The same way, the potentials, if no current passing along this line, so the same way no current passing along this way, this line. No current coming in because no current going out. So therefore these potentials at these points also should be equal but different than this one. Therefore I use green color for this side, because there is a E, capital E, that means electromotive force. Therefore these two are not equal, but these two are equal, and separately these two are equal. So always there is a current along this circuit, so there must be a switch here. If you draw like this in the exam, you don't get marks. You don't get marks without a switch here. Therefore there must be a switch like this. Remember, when you draw the circuit in essay paper, suppose, you must include the switch like this. So when the switch is on continuously, there is a current along this loop like this. So this wire is a resistor wire. It has a resistance. Therefore there is a potential difference. There is a voltage between these two. There is a voltage because there is a current. The current is this one. There is a current along this resistor, that wire, and also there is a resistance. Therefore it has a voltage between these 2 points. So that voltage is equal to this potential, this electromotive force when there is no current. Here I equals 0. When there is no current, this voltage must be equal to this electromotive force, because here between this green dot and blue dot, the voltage is E given by this cell. So that T you can see green dot, blue dot, blue dot. Therefore this E should be equal to this voltage. So therefore we can write E equals this voltage, but this voltage is equal to K times 60. We can write like this then. What is K here? K is the potential drop per centimeter, that means per unit length. Potential difference per 1 centimeter. So if it is the potential difference per 1 centimeter, so there are 60 centimeters. So the total potential difference we get by multiplying this K and 60. So that is equal to, that V is equal to E. This value is V, but that is equal to E according to this argument. What? When there is no current, the potentials at these points must be equal. There is no potential difference, and also there is no potential difference between these 2 points, and also potentials at these 2 points must be equal. So like that we can develop the argument. So this is the equation then. The same way, so that is what I initially have written here. So the same way, when there is no current through the galvanometer in this second circuit, but there is a continuous current along this line, because the switch is closed, there is a current like this, and also there is this current still. This one also should have that switch, plug switch. So this one has a current when switch is on, as previously, continuously current is flowing, the same I as this one, this I, same as this I. So therefore there is a potential difference again, because this one is a resistor. There is a potential difference. So that potential difference is equal to the potential difference given by the circuit, the secondary circuit, we call this one. From the secondary circuit, the voltage is given red V, I have marked it in red color. So this potential difference must equal to this voltage. Why? As I said previously, these since there is no current, I equals 0 here, there is no current through the galvanometer, that is what we call the balance point. So balance length they have given. At the balance point there is no current. If there is no currents, there is no potential difference between this, delta V equals 0. Potential difference, if potential difference is 0, there is no potential difference, then potentials are equal, no difference, blue. Here also same. If there is no current here, the current must come from here, but if there is no current here, there are also no current here. So therefore this line also has no current, therefore this potential must equal to this potential at this point. There is no potential difference, delta V equals 0 here also as well. So therefore the potentials must be equal between these 2 points. So therefore this red color voltage is the potential difference, but here there is a potential difference, that is why I used blue and green colors, because that is E O V. So here it is not E, because the switch is closed, there is a current here, so the E drops, E doesn't stay at that highest place, it drops because the current is passing. When there is current, E drops because there is a simple R in this cell. So now the value is V, we have to use, not E. The value is V. So this V equals to blue color V from the primary circuit, like this. This V is equal to this one. So this one is what? This red V is what? This one, red V, red color V. I have to then color it like this. This is that V, ER divided by R plus R. So that is why we substituted this V. This V is blue V. This one blue color. This one. Blue color V equals K times 50. Red color V equals ER divided by R plus R. So we can, therefore both are equal. Therefore we can substitute as previously we did. So again I can do it. Instead of red color V, we can now substitute K times 50, because this blue color V, because they are equal, 50 equals E means this one also, that we can substitute K times 60. Then the resistor value is 10 plus simple R. So this way we can simplify, and we received R equals 2. So children, this cell at the primary circuit must be an accumulator, because to get a constant current for a long time, they ask in exams what is this, what sort of a cell you have to use here. They have asked, and will ask in future papers. So you have to write it is an accumulator. They ask why. So the reason is to get a steady current for a long time. This wire is a resistance wire. It should have a constant resistance in each centimeter. That is uniformly. It is a uniformly resistance wire. It should have a uniform resistance. It is made of manganese. So I think I have explained everything here. So let us wind up this problem. And also you should connect the positive terminal of this accumulator to the positive terminal of this cell, like this. This side, the left side should be positive, otherwise this won't work. And you should use a 5 kilo ohm resistor to protect the galvanometer. 5 kilo ohm resistor here to protect the galvanometer. That is the value. You can't use 100 ohms, 50 ohms, something like that. You need 5 kilo ohm resistor. So children, I think you are happy because I explained everything. So if you are happy, please subscribe my channel, and don't subscribe twice. If you subscribe twice, the subscription will be cancelled. Therefore, if you haven't subscribed, then only you have to subscribe. Thank you very much for those who subscribed my channel, and thank you very much for who watching my videos again and again. You don't have much time, children. Exam is coming soon, so do work hard. So see you tomorrow. Goodbye.